Ray Kurzweil, one of the most famous AI scientists in the world, once said that AI would reach human level by 2029 and the singularity by 2049. In his most recent book, he's actually doubled down on this. One of the biggest questions that I've heard asked in the industry and for people who have no clue about AI is, what is ASI, what is AGI, and when have we or will we hit one or both? This is a very complicated question, but in today's video, I'm going to try to break it down for you in 15 minutes. So first, let's think about definitions. There are two terms that we want to use when we're assessing the progress of AI models, LLMs, and beyond in their performance against humans, AGI and ASI. AGI stands for Artificial General Intelligence. ASI stands for Artificial Superintelligence. So the question is, what is each one? And the answer is actually a little bit more complicated. It changes from person to person. OpenAI's exact definition is a highly autonomous system that outperforms humans at most economically valuable work. For artificial general intelligence, AGI, and for ASI, artificial superintelligence, an individual by the name of Nick Bostrom, who's one of the most famous people in AI, says it is an intellect which is much smarter than the best human minds in every field. So to effectively sum that up, AGI is taking the top verticals for humans and solving them in a lens towards economic growth. But ASI is better than the top humans in every single field. So ASI is obviously a far more advanced version of AGI. And one of the most important things to remember in anything really, but specifically in AI, is the Pareto principle. 20% of the work yields 80% of the results, and 80% of the work yields the remaining 20% of the results. So to that end, AGI will take much less work than ASI, because once you are able to optimize for the top level verticals, going deep into every field will take the most amount of work, even though we are only going to get 20% more advanced from a general perspective. Obviously, for specific fields, we would become much more advanced on the models. But in terms of the actual overall economic impact, having an AGI is much higher per capita than it is to have an ASI. So these are the conventional definitions, right? OpenAI and Nick Bostrom's. But these definitions differ from person to person, right? Some people define AGI very differently. Some people say that it should outperform the best performers in these economically viable fields, while other people say it should just outperform average people in those fields. Like, for instance, if you take coding as an example, people might say that my definition of AGI is you have to outperform the best coder in the world at coding from the model. That's one potential definition. But another person could completely say that, no, it just has to outperform the average software developer. It doesn't have to go and beat like some of the best people in the world just yet. So there are a lot of different definitions of AGI and ASI. I personally have a definition that I want to share and what I believe has been accomplished today. What I wholeheartedly believe is AGI refers to a base model that can be adapted using reinforcement learning or supervised fine-tuning or agentic pipelines or prompting, right? Can be adapted or constrained to execute a certain task better than the average performer in that task. I think we've already shot past that goal. And let me tell you why. There are so many application layer AI companies out there that are taking over so many different aspects of life that people don't want to have to think about. For instance, transcribing meetings and taking notes. There are like a million note apps out there which do a much better job than any human can at typing, just because it can take the audio transcript and transcribe it in very fast time. However, if you look at some of the top questions like HLE, Humanities Last Exam, which is a benchmark of some of the hardest questions to ever pose LLMs, most models still highly underperform on that data set. So that's the distinction between AGI and ASI. So I would honestly argue that for this definition of AGI, we have blown past the definition, where if you have a really strong base model, you're able to adapt it to focus on specific use cases in a way that's beneficial to everybody. However, it's very contingent on the definition of AGI and ASI. And what I think is very important is a definition of AGI and ASI becomes public to the world, that is consistent with what people who don't know anything about AI think. And the reason that I say this is because those, for the most part, are going to be the end users, right? ChatGPT has 700 million daily active users. Most of these users don't know how to interact with ChatGPT using the API. A vast majority don't. And this is just 10% of the world's population. If you scale it up to the full 8 billion people, there's going to be a vast minority of people who can even just make an LLM call through API, let alone every single individual understanding technically how the model works. So understanding the user definition of AGI and ASI is going to be just as important, if not more important, than understanding the researcher definition, because it can be hard to set internal goals for AGI and ASI and execute on them, but it is easier to have the goals set for you. So let's look at today's example. OpenAI and Google DeepMind's Gemini just recently participated in ICPC, which is a college-level competition for some of the smartest people. And the top team only won 11 out of 12 problems. They got one wrong. ChatGPT's GPT-5 was able to solve all 12 correctly, obviously taking multiple tries, but it was able to solve all 12 correctly. And Google DeepMind's Gemini was able to solve 10 out of 12 questions. So while they're relatively close, OpenAI's ChatGPT did beat out all human participants in this incredibly hard college-level competition. So with this in mind, we really have to evaluate to what extent we have reached AGI, where it's defined as beating the top people in economically viable verticals. So there's a very interesting article written by this person named Sean Wang. He was formerly at Cognition. And what he says effectively, and I'll read this word for word, is coding is the pair 2 of AGI. Similar to this pair 2 example that I gave of economically viable verticals versus all of the verticals, Sean Wang is actually saying that code AGI arrives in 20% of the time and captures 80% of the value of AGI. And I completely concur with this point. The reason is there are multiple different verticals that an LLM or whatever AI you're using can work in. It can work in linguistics related work, right? It can answer your questions. It can generate, text for you. It can try to answer math and science questions, and then it can kind of have an emotional sidebar. For linguistics, LLMs still fail on very simple questions. How many R's are there in strawberry? Like, the LLM cannot get that right. It'll say 5. And the reason is the tokenization can change very significantly. And I'm not talking about an LLM which can make searches on the web, because obviously you can figure it out from that. I'm talking about some of the lower level LLMs today can still not answer this question consistently. But let's say you prompted the LLM, write code to tell me how many R's there are in strawberry. What will then happen is the LLM will write a code cell saying, okay, our string is strawberry. Can you just, write a for loop? And it'll go through each character and compare it to R. And then it'll tell you, increase a counter. And it'll tell you, there are 2 R's in strawberry. If you can do that, the code will run super quickly. right? The LLM won't have to waste compute on questions like that. That's code AGI, where effectively coding is used to solve questions that would eat up a lot of the LLM's time and compute, right? For instance, give me the answer to the super complicated triple derivative math question. It will waste a lot of compute trying to figure it out natively, or it can just write code saying, okay, why don't you use the derivative function, the built-in math derivative function on Python, run it thrice on the same thing, and just spit out the output in a presentable format. That's code AGI. So that is one key vertical that we need to certainly analyze as it goes forward in AGI specifically. That's one. Another one is competitions and Olympiads, kind of similar to what this ICPC is going on. That's very clearly the researchers at OpenAI, Anthropic, and beyond are doing a phenomenal job building the model so that it can perform in that capacity. So that aspect is already being looked into very heavily. But the third aspect, and the biggest reason that I am still a little concerned about whether the model can be considered ready for human consumption, is the security aspect and the ethics aspect of the models. So models can be jailbroken still, right? I mean, models have gotten better and better at this, right? If you fed the old ChatGPT in like an old prompt called a DAN, do anything now prompt, it would completely break and it would completely follow anything that you said. But obviously those kind of prompts have been completely cleared out. So if you wanted to jailbreak some of these models, you would have to do some manipulation of the weights, and obviously that's usually only done through open source models, unless you're like a fantastic researcher and you have a really deep understanding of the model, in which case you can try to jailbreak it through interacting with it in UI. But the problem with that is also ChatGPT is being very restrictive in banning anybody that when they see a hint of any concerns. So it's gotten harder and harder to jailbreak, that's for sure. However, at the same time, there have been some really revolutionary evaluations into how ChatGPT and other LLMs are impacting health, mental health specifically. So there's been a lot of groundbreaking research happening into observing both sycophancy, which is when the model simply listens to you, does whatever you say, and evaluating, hey, is the model being supportive? Is the model helping you do the right thing? Especially when it comes to as high pressure, high risk situations as when somebody is interested in taking their own life. And ChatGPT and most of these other models have like 20% success rates on evaluations of this topic. So that's one of the aspects of AGI that I don't think is fully there yet, which is the human aspect. Obviously, it's very hard for us to actually build a sentient artificial intelligence. Like, that's still very much science fiction. But I do think the aspects of ethics are still missing in a lot of these models, and they need to be trained. And it's not like it's the researchers' fault, right? The researchers are optimizing for high performance models that are able to give you really high quality answers. But at the same time, it's very important that these LLMs deeply love and respect humanity. And right now they're algorithms, right? They're going to continue to be algorithms, but it's very important that without being sycophant, without crossing that line, without, providing unnecessary impacts to humanity, it also knows how to protect human life. It also knows how to protect human values. So that's an aspect that still needs to be worked on. That's an aspect that models still need to get better at. So that's AGI. That's the AGI camp of things, artificial general intelligence. Artificial superintelligence is a completely other, different story. And that's where we get into the sci-fi, right? I mean, don't get me wrong. I already feel like we're in sci-fi land right now. What I was discussing is super consistent with Asimov's robot principles. But the ASI spectrum is something completely different. And Sergey and Max Tegelmark and my definitions of AGI are pretty consistent. Or not AGI, rather, ASI. So Sergey has said that an an ASI, artificial superintelligence, will be able to instruct itself. It'll be self-learning. Max Tegmark has written a book called Life 3.0. He says there that he gives an example of an AI called Prometheus. And he says Prometheus will be able to replicate and build better versions of itself. What these two separate views and my view are referencing something called self-learning, where the model teaches itself to be better. It's in the name, self-learning. Like, let's say you have to teach yourself a math concept. You go online, you search Khan Academy, and you learn it. But the problem with the self-learning model is at some point, the model is going to get better than humans. It's going to be like, I mean, that's the literal definition of ASI, where it moves past the experts in every vertical. And then the question is, there's no Khan Academy. So how does the model iteratively discover and build itself to discover better in each vertical? That is the real ASI. And that is really challenging, because what you're doing there is you are replacing researchers. So I honestly don't see a path to ASI right now. I mean, of course there's a path. Don't get me wrong, there is a path, but it is a very distant path. So I feel like a lot of the people online are divided into two camps. The camp of people who think that AI is completely incompetent. It has nothing, it's just not good. And it doesn't have any potential to do anything in our society. And this is the camp that call people clankers. Not people, they call the AI models clankers. So that's one side. And the other side is the people who are very scared of AI, and they're like, AI is going to take our jobs. So interestingly enough, you can look at it in the context of the definitions. The people who are saying the clanker stuff, they are underrepresenting the performance of AI models, and they're not recognizing that varying based on the definition, we have hit AGI, right? But the people who are on the other spectrum and they're saying AI is going to take our jobs, AI is going to like cause a complete economic collapse. They are overestimating the model's performance, and they are moving towards like ASI, which is very far. So we are somewhere in the middle, right? The AI models are not useless. They're not bad. In fact, they're quite phenomenal. But at the same time, they're not going to just come for your job just yet. So I think it's very, very interesting to watch where this goes from both an ethics perspective and a scientific perspective. And I think that really deeply thinking about the implications of these technologies for the future is going to be an important skill for everybody. So I would say that closes out this video. To sum it up, we've discussed the difference between AGI and ASI, general intelligence and superintelligence. We've discussed some varying definitions, and we've discussed, based on my views and the views of some people around me, and not around me, but some of the individuals who are in the ecosystem, how is AI progressing? How is AGI progressing? How is ASI progressing? Are we somewhere in the middle? Like, where are we on the progress scale? And then we discussed some of the implications of people not understanding the difference between AGI, ASI, and misrepresenting the potential and progress of AI. So I think that quite clearly answers the question of, are we at AGI yet or ASI yet? And the answer is, it depends on how you define it. And this is a very philosophical debate. It's not it's not really a deeply technical debate, because you can then ask ChatGPT, hey, ChatGPT, I have this definition of AGI, ASI. Does any model meet this yet? So the technical part telling you, hey, we meet this definition of AGI, we meet this definition of ASI, is very possible with ChatGPT. But that definition, that philosophical definition, is very important to internalize. Why? Why is it important to internalize? The reason is the definition of AGI and the definition of ASI that matters the most are from people who are not technical, who don't understand what AI is, because that's the kind of technology that they're expecting to see. That's the kind of technology that they think is going to have an impact on the world. And they are the consumers, they are the end users, they are the people who are going to be using this application. So their voice, your voice, if you're not deeply technical, matters just as much, if not more, than us technical people. Thank you so much for watching this episode of Neural Bridge. Please make sure to like and subscribe. And I'm going to make sure that I'm being consistent and uploading every week with that cadence and making sure that you are informed about uploads. So if you're interested, please like, subscribe, and press that notification button so that you know when a new video is being dropped. Thank you.